recording now. Okay. So today we're going to do a 3D mole circle question. Okay, I'm going to do the one a lot of question a lot of students ask. Then I will look at the one Enrich asked. Okay, so let's look at this question. The answer looks simple. Okay, like always, the answer looks simple, but the question is why. Okay. So I'm going to copy the whole thing. I'm going to paste. Okay, too big. String it down. Okay, I repeat again. The solution looks simple, but why is it done like this? Okay, so let me. So this is example number 1. Or this I'll put it under 3D mole circle. So this element, there's something wrong with my. So this element, okay, is a 3D mole circle element because you have stress X, Y, and Z, and you have a shear in the XZ direction. Okay. So we are asked to determine the two values of stress Y. Okay. So question asks us to determine two values of stress Y. Okay. And this question seems to be less complicated than the one that I show in class before. Okay, so this one seems easier. Why is that? Because stress Y has zero shearing stress. I repeat again, point Y over here has zero shearing stress. Okay, so this is my point X, and this is my point Z. In the example I did, you have shearing stress in stress Y. Okay, so this is what is given. So we know that stress X is equal to 90 megapascal. Stress Y is what we don't know. But stress Y is controlled by, we are given by the maximum shearing stress. Okay, either in plane or out of plane is at 80 megapascal. Okay, and then stress Z is equal to 0 megapascal. And we are given that shear XZ is equal to shear ZX, and this is equal to 60 megapascal. Okay. Now the confusing thing is it 60 positive or 60 negative. Okay. So don't worry, it's all dependent on the rotation of the element. It all dependent on the rotation of the element. So let me elaborate what I mean. So if I put if I were to put my transformation this way, okay, and now I can't see the question. I need to be able to see the question. So if this is my X and that is my Z, why I put it this way? Because that's the orientation where going up is positive, going towards the right is positive. That's the only reason. And then if I were to superimpose an element, okay, superimpose an element over here. So we can see that if I'm going to put in the numbers now, this is where we have our 90 megapascal. Okay, the X. And over here, this is where we have our shear of 60 megapascal. So we know that at point X, okay, what is the rotation of the element, and also at point Z. Okay. Now, this is for this problem, it's not so important whether clockwise or anti-clockwise, but the way I teach, I think I want you to get it right. Okay. Now, before I go on, there is a bit of misunderstanding regarding the term test in terms of when I ask you to do correction. Okay, let me clarify that first before I go on. And I think this was mentioned before. So this is only for term test. Final exam, we can't do it, okay? Term test only. So all of you have done your term test, okay? If your overall grade, okay, is above 50%, okay, there will be no correction. Okay, there will be no correction. Okay, so we know that our overall is out of the maximum grade. You can get 20. So if we have question 1 and question 2, if question 1 you get 7, question 2 you get 4. No doubt question 2 you need one more mark to be 5 to really understand, but your overall grade is 11. Okay, there'll be no correction. I can give you another example. If this one you get 10 and this one you get 0, your overall grade is 10. I will still not ask you for correction. Okay. Now, if your overall grade is below, if your overall grade is below 50%, it's a different story. If this one you get 9 and this one you get 0, right? This is equal to 9. I will ask you to do a correction for question number 2. However, the best mark, okay, best grade you will get for this case is a 10. Okay, so if this question you just get a 1, okay, or this question you get a 5, I will only consider 1 mark only. Okay, so the purpose of the correction is for those that fail, okay, objective. Okay, so the objective is those that fail or below 50 to get a maximum of 50%, okay, after correction. Are we clear? Okay. Okay. So it is not, I like to declare this, okay, it is not to improve, okay, improve the grade after passing. Okay. So i.e. if you get above like 51% or 50%, okay, it's not for you, okay, I want to do correction now, I know how to do it now, okay, I want to do it better. Okay, are we clear about that? Anyone have any question regarding this issue? Anyone, please? I hope this is clear, not to create any confusion. Alec, you have question?
Just about the final exam. So for the topics on the final exam, is it only what we cover in class, or will it be like all of the topics going forth to the last week?
So if I were to show you last week's lecture, right? This is just part of the lecture. This we calculate moments, we calculate torque, everything, right? Now over here we have found that we also include shearing stress, yes or no? And you still need to apply this formula. So Alec, am I making sense or no?
So cumulative?
So yeah, you cannot forget what you learned in week 1 or week 2 up to today. You still need to have that knowledge to solve it. However, the big percentage will be the big percentage will be given to how you break down the loads into moment and how you from the stresses you go into mole circle. Is that understood, Alec, or everyone?
So if we like, because we have to cover the deflection and beams and other things like that.
Yeah.
If we don't get to that in class, will it be on the exam or will it be like self-learn type thing?
Alec, I always believe in fairness. So what do you think?
So no.
If listen to all of you, okay? If any, I'm the program chair for manufacturing. If any of my instructor dare to test you stuff that has not been taught yet, okay, you let me know. I'll come after the person. Alec, does that make sense now?
Yeah, thank you, Eugene. Also,
Okay.
just one more question. Do we need to pass the exam to pass the course?
No.
Okay.
Okay. You don't need to pass the exam to pass the course. Okay. There are sometimes good days, sometimes bad days, for crying out loud. Okay. Now, is that all the question? Yeah, so I don't see it. So the objective is this, okay? I think we are at a stage now that even without the final exam, I can give you your final grades now. I will tell you that, okay? Why? Because you have put in your best and it's the honest grade, okay? So even without the final exam, I can put on your grade wholeheartedly because I'm answerable to society, okay? So yeah, you don't need to pass your final. I know some instructors have that rule. It's up to them. Okay, I'm not going to impose that rule on you guys. Okay. So are we clear regarding this issue regarding corrections? Okay, I know there's a bit of misunderstanding, but I want to clear the misunderstanding. Okay, let's come back to this question over here. Right. So we know that where we are is I stopped where to mention that this is going to be positive shear. Okay, with this is going to be a positive shear situation. Okay, so now we are very clear with that. So we are asked to find the two stress Y value. The saving grace, the difference of this question, as I mentioned before, is at point Y. Okay, point Y. There are no shearing stress. Okay. So if we were to look into the problem with the solution manual is they just draw a circle like that and go, okay, we are good to go. Okay, we are the answer, boom. But why is that the answer? Okay, as I mentioned, this is a 3D mole circle issue. Shouldn't we see 3 circles, not 1? Am I right? Okay, so I'm going to show you how this should be done properly. Okay, so we are going to construct a mole circle. Okay, we're going to construct mole circle. If any question, you just ask. Okay, don't hesitate. Okay. So because we know the limit, so I'm going to start from minus 60, 40, 20, 0, 20, 40, 80. Okay. So this is normal stress. And then we are going to look at our